Chatri Gold Mine is located 3 hours north of Bangkok in a rural environment where the principal productivity is rice and dryland corn cropping. Following many years of exploration and planning, approvals were sought from the Thai Board of Investment, the Office of Environmental Policy and Planning, and the Department of Mineral Resources. Construction of the mine commenced in November 2000 and was completed in just 12 months, at which time the first doré was produced at the mine. Prior to the approvals, it must be determined exactly where the gold-bearing rock lies beneath the surface. This was achieved by drilling many holes into the ground and analysing the samples. A picture of the shape of the ore body can then be made, allowing a mine plan to be produced detailing how much ore and barren rock needs to be mined and the shape of the finished pit. Mining the ore requires even greater detail to be known of the amount of gold and silver contained in each bucket load of rock. Drilling on the pit floor at very close spacing is carried out and the samples are logged and analysed. When the rock is too hard to be excavated, it must first be drilled and blasted to fragment it. Using the assay results, complex calculations are carried out using a specialised computer program to determine the outlines of ore of different grades. These outlines are then transferred very accurately to the pit floor to indicate varying grades of ore. Excavators under the direction of a geologist remove the ore and barren rock. Ore is carted to the run-of-mine pad where it is stored in heaps, ready for processing. Rock that has no gold in it, but that needs to be removed to allow access to mineralised rock beneath, is carted separately to the barren rock dump. This material will gradually form a hill which, when mining has been completed, will be planted with trees and grasses to prevent erosion. Gold and silver need to be removed from the remainder of the rock by crushing, grinding and leaching. Ore is fed from the stockpile into the crusher using a loader. The ore is crushed by a large jaw crusher to be 95 mm or smaller. Water is added when required to suppress dust. This process is controlled by computer operators to ensure an even flow of ore and to prevent blockages by large boulders. Crushed ore is fed by conveyor to a stockpile and from there onto a second conveyor for delivery to the grinding mill. The grinding mill is a large drum-shaped vessel containing metal balls which assist in reducing the rock to 75 micron size. The SAG mill product is pumped to a set of cyclones which ensure only the finely ground material proceeds to the next stage of the processing, with coarse material returning to the SAG mill. The crushed rock is fed into the first of a series of 7 tanks, where by the careful balance of chemicals, the gold and silver is dissolved from the rock, then adhered onto carbon particles, while the ground rock particles flow from tank to tank. The carbon with the adhered metal is removed from the first tank, and in special confined vessels, the metal is stripped off using a strong cyanide solution. The barren carbon is regenerated by heating for reuse in the tanks. The metal containing liquid is pumped to the electrowinning cells housed in the gold room, where an electric current causes the metal to be deposited onto large cathodes as a black sludge, which is then washed off, filtered and dried, ready for smelting. This is carried out in a large furnace, and when the metal is sufficiently fluid, bars of combined gold and silver doré can be poured. Cyanide is used in the 7 leach tanks to dissolve the metal from the ground rock. Before the leached ground rock is released to the tailing storage facility, the remaining cyanide is reduced in the cyanide reduction tank to levels that are safe for wildlife. The detoxified ground rock is pumped as a slurry through a pipeline surrounding the tailing storage facility. It is released into the facility through outlets spaced around the perimeter. Different outlets can be opened in turn to ensure an even dispersion of the tailings. Water is rapidly drained off the slurry, leaving the ground rock or sand to dry out further. A variety of bird and animal life use the area as a habitat and water source. Excess water is returned by pumping to the process plant for reuse. An on-site laboratory is equipped to analyse rock samples from the pit and daily samples from the processing plant. A well-laid-out office houses the management and staff, where they are able to discuss plans for mining and processing on a regular basis. A first aid room is attached, and an ambulance is also available for emergencies. Many extra buildings have been erected around the site, including stores areas and workshops. Chatri Mine provides a meal at the canteen for all personnel each shift. This facility is provided by local contractors. An external contractor is responsible for all mine security, including access to the site and internal security. A higher security level is provided for access to the plant site, and higher again for the gold room. Akara Mining built an electrical substation near the mine site to provide reliable power from the Thai grid for the plant. The mine is self-sufficient in other services, including water. A modern world-standard gold mine has been constructed by Akara Mining in rural Thailand. Employment and expertise have been increased in the local area and will continue to be a feature of life to the benefit of the local community here for many years to come.